Okay, so we're going to learn a few new things about roots, and specifically, well, the first one's the most mind-blowing. So we already know that we have square roots, right? So let's say the square root of 16. And another way to write this is with a little index number of 2. We typically don't put the 2 there though, right? But that helps us understand what it is. And I think we'll just use the principal square root, which is the positive answer. So the square root of 16 is 4, right? Because 4 times 4 is 16, or 4 squared is 16. Well, there's another way of writing roots that don't use this radical symbol. And that's one of the things we want to mainly explore. Okay? Another way to write this is the following. In parentheses, I'm going to write 16, and then I'm going to raise it to a power. You can actually express roots as an exponent. Did you know that? We're going to do that right now. It's to the 1/2 power. The square root of 16 can also be written as 16 to the 1/2 power. Okay? And let me prove it to you that works. I'm just trying to get the focus a little better. Okay, that's better. So you may be saying, how does that work? Is that possible? This is kind of mind-blowing. Every root can be written without that radical symbol, this little radical symbol, but instead with an exponent. Turns out it's going to be a fractional exponent. Let me prove it to you. I'm going to rewrite 16 the following way. 16 is 4 squared, correct? And that's to the 1/2 power, right? Now we're going to use our little rule. This is a power of a power, right? So Giselle, close the Chromebook right now. What do we do when we raise a power to a power? Multiply. So really what we're doing is this. Well, I'll get there. I just don't want to lose anyone. 4 to the 2 times 1/2. And that's just 2 times 1/2 is 1. So it's 4 to the 1, and 4 to the 1 is just 4. We're not going to do it this way each and every time. But basically, we get the answer that we're looking for. Okay? So there's a way of expressing every root, square root, cube root, fifth root, 1,000th root, you name it, as a exponent. So this is called the nth root. Okay? And it's pretty simple. Say you have the nth root of a. Another way to write this is a to the 1 over n. That'll work with anything, any root you give me. Okay? So it doesn't even have to be as long as it's a positive real number, I believe that's all. So it could be a fractional number, a decimal number. It could be pi. If we want the pi root of a, it would be a to the 1 over pi. We're not even going to go there, but it's possible. Okay? So this is the major concept we'll be exploring for a couple of days. And we'll be doing a couple things with it. Now, what is important is if we're dealing with like just whole numbers, if n is odd and even, then certain things are going to happen. So we should probably write those down. Okay? So let's do this. If n is odd, okay, so if n is an odd number, then you have one real root. I think it's at least one real root. Okay, so you're going to get one answer each time. Okay? Well, now here's what happens if it's even. If n is even, oh, yeah, that's important. So if n is even, you have two real roots. That's why when we have square roots, we have pairs of answers, the positive and the negative. So the positive and the negative, we're going to use that plus or minus sign, whatever a to the 1 over n is. Okay? So you're going to get pairs of answers, the positive and the negative. So this works for 4th roots, 6th roots, 8th roots, 10th roots, etc. All right. Okay. Now, say you have 0. This would be 0. Okay. So the nth root of 0 is going to be 0 each and every time. And probably the most important one to remember here, well, along with when you have even roots, you're going to have pairs of answers, the positive and the negative. If n is even, and a is negative, then, I forgot the f again. If n is even and a is negative, then if you have this, remembering this is some negative number right now, you're going to have this, of course, but is not a real root. The answer is not going to be a real root. So if you have, for example, something like, I'm looking for my black pen. Yeah. So for example, let me push this up a little bit. If I have the 8th root of negative 20, if you're looking for the 8th root of negative 20, basically it's some answer, but it's not a real number. So you could just say no real root. Okay. Let's see. But if I ask you for the cube root of negative 125, first of all, let's write this in that new format. How would I write it? Negative 125 to the 1/3 power. I could write it that way. And let's see here. 125, isn't that basically negative 5 to the 3rd root, and all of that to the 1/3, right? Negative 125 is really negative 5 cubed. And then using the rule that you product of powers, you multiply the exponent, so you got negative 5 to the 3 times 1/3. And I can cross cancel these. I get negative 5 to the 1, so it's negative 5. Okay. We're not always going to write all this out. It would have just been much quicker to realize negative 5 times negative 5 times negative 5. Yeah. But I just want to show you how the whole process works, because on some questions, we are going to have to expand this out. Okay? Any questions so far? All right. Now, let me throw a variable at you. 3. Let's say I have the 5th root of x to the 30th. Whoa. Go ahead and write that down. I don't even know how to deal with that. How could we possibly work with that? We got a couple things going on, right? We have some power inside here, and then we have some power out there. Well, we need one more thing I got to show you. Okay? So check this out, and then we're going to come back to this. So here it is. If you have the nth root of something raised to a to the m power, okay, you can rewrite this as a to the m nth power. Okay? Go ahead and write that down. And that's another one of those important ones we want to box, because it will be coming up quite a bit. So we have the nth root of a to the m. Another way to write that is a to the m nth. Basically make it into a fraction. The numerator of the fraction is the power of the base, and the denominator is the root. Okay, so let's write that down. Numerator is the power of the base, So that would be m. And the denominator is the root, n. Okay, so now let's go back to our problem over here that we were working on. Let's rewrite it in this format. We have the fifth root of x to the 30th, and we want to simplify that. You ready? Let's do it. Okay. Well, I want to write it in this format. How would I write that? X to the 30th over 5. Okay. X to the 30th over 5. Wow. Did that help us though? Can I do anything with 30th fifths? Simplify that, right? Yeah, simplify. You see a fraction. Doesn't matter if it's even if it's an exponent. If we can simplify it, simplify it. What's 6? So what's my final answer? X to the 6th power. Okay. That's basically how this is useful in simplifying stuff like this. Otherwise, we would have had to have broken this up into x to the 5ths. We would have had 6 of those x to the 5ths, and it would have been a mess. This is much quicker. Okay? Any questions? All right. Let's see here. So let me give you something like this. And I want you to give me the answer. For -8 times the cube root of 8. I'll give you a hint. First, figure out what the cube root of 8 is, and then multiply it times -8. Try it.
8 times, I can try this, -8 next time, try at least 3 times 8.
Yeah, you could do that.
But then, what does that mean if possible, or like, is it not allowed to distribute?
Well, you're not really distributing, you're just multiplying. If we had more factors inside that we had to multiply through to, then yeah, you're right. I see what you're saying. So these are just two numbers that I'm multiplying. One is -8, the other is the cube root of 8. And so what's my final answer? -16. Okay? Not too difficult. All right. Okay, number 5. Let's try it this way. -16 to the 1/4 power. It may help. I don't know. It may help maybe if we rewrite it with a radical. So if I'm using the radical, it would be 4 is the index. And what number goes in here? So we're looking for some number that multiplied 4 times would give you -16. Yeah. Even. So you could say undefined, no real roots. At this point, I think it's better for us to write no real roots. It's defined as something, but it's an imaginary number. So we won't we won't deal with it too much yet. Okay? Again. All right. So, okay. Number 6. Let's try this. The cube root of 8 x to the 24th. And this is about as tough as they'll get. Okay? So, I'm going to break this up into two things. It turns out I can break this up into two factors. I have 8 as a factor and x to the 24th. Two separate factors, right? So I'm going to do this. 8 to the what power is if I want to write this as an exponent? 1/3. And then we're going to multiply that times x to the 24 to the 1/3. Okay, I just broke it up into two. So now I want, what number times itself 3 times gives me 8? 2. And then the other one is x to the, I'm going to use this rule here. I'm going to use this rule. Since I have a power to a power that's 24 thirds. Simplify that. 8. 2x to the 8. Okay. Any questions? All right. Let's try a few more like this. Let's do number 7 and we'll call it 5th root of negative 32 x to the 15th. Okay, let's break it up into two parts. Maybe you didn't like it this way. If you like for the number, it really won't matter if you put it into exponent form. So I'm going to show you a different way. If you don't want to write it to the 1/5 power, you can also leave it this way. 5th root of negative 32. You could leave it that way. But the other one you should definitely write it as x to the 15th to the 1 over what? 1 over 5. Okay. So now let's see. We're looking for a number that multiplied 5 times gives you negative 32. Negative 2, yeah. The 5th root of negative 32 is negative 2 times x to the 15 fifths, or 3. So this is negative 2 x cubed. You just simplify 15 fifths to 3. Okay. All right, how are we doing? I know I threw a lot at you here, but this is the beginning. We'll do a little more tomorrow. But basically, this is what we're going to be working with, working with higher power roots and simplifying them. Okay, so I probably would recommend having a calculator handy.